Hello, welcome to this short video presentation we will make. My name is Cyril Noger. I'm a RF and wireless field application engineer based in France, mainly supporting the French territory, but also some part of Europe. I will be introducing you today the capture and replay function that is available on all our VSA models, RF models below 13.5 gigahertz, where you can get a vector signal generator inside the unit. So the main interest of this unit, the main advantage of this unit is that we can play with totally independent functions like the VSA, vector signal analyzer, the spectrum analyzer, and the VSG that is called vector signal generator. So all these three functions are totally independent. The goal today of the demonstration I will do is just to explain you how the VSA is acting to capture a signal on the VSA port, so the end port we have on the right side, capture the data, digitize the data into the internal computer, convert it by a simple one press button that we will use, convert this file into a waveform that will be physically generated thanks to the vector signal generator inside the box. What this capture and replay function does really are explained on this slide. It does the A to D down converter, convert it to a waveform, stored in the internal hard disk of the unit, and then being generated, loaded into the arbitrary memory of the VSG before being outputted at the right frequency at the same level that has been captured by the VSA. So it's pretty simple. It makes life easier for the customer. There are really only two steps thanks to this function, rather than playing with an internal software that we can use as well. All the steps would be used or would be explained this way. So the capture and replay function does the job for the user, which is really not time consuming and really interesting to use to get things done properly without any error. We can use IQ Producer, which is one of the software we provide with these units, just to do the job, but it will be done manually rather than automatically. So today, the presentation will be based on a Tpms device. Tpms device is this kind of device that you get on your tire on modern cars. I will have to make a reset of this device just to generate something. Thanks to the VSA, I will capture this pretty short information, which is like 10 milliseconds long, and the VSA will do the job to capture and replay the signal like if it would be live afterwards. This is the basic information or basic drawing that we can summarize. I will be using an antenna, the Tpms device, and then the demonstration will be done. So now we will focus onto the unit, and I will show you how to perform this information, this function, and how the VSG will then output the signal. Okay, so now let's focus on the unit. I will explain you in more details what I will do to get this capture and replay function working properly. So in this MS2840 VSA unit, we have the advantage of having few different functions. One is the spectrum analyzer that we see at the moment. One is the VSA function. And the advantage of such a platform is that we can have on RF models the VSG, built-in VSG. So this demonstration will focus on how I will digitize the signal that will be processed internally, converted internally, and output on the VSG to be replayed physically speaking. So this is what I will try to demonstrate at the moment. So let's try to focus on the device I will show you. This is a Tpms device, tire pressure monitoring system, that is used in most of all modern cars by now. It is warning the driver when you are getting an insufficient or inflated tire, so before you get a flat tire. So what I will do is that I will need to make a reset on this device to get a signal generated by the device, captured by the VSA, and then I will play with the different functions just to show you how the replay, capture and replay function works. So let's focus on the VSA first. I will switch to the VSA. I have prepared my slides, my setup, just to be sure that the VSA is waiting for the signal to be captured. So I will make a reset on this device. Now you can see on the screen that the signal has been captured, so it's not live anymore. And then my goal is to digitize it, capture it, save it, and convert it internally in the computer that is in the product. So I will go to the main menu, go to the capture function, go to the capture and playback function. I will not take care at the moment about the name that will be given to the file. It will be time-stamped, and I press the execute capture and playback function. Now it does the job on its own, which is quite easy and not time-consuming. Now it's done. The VSG is ready to generate physically the signal, and then I will forget about my antenna and just replace the antenna by the VSG. As you can see, now it's live. I will make it live on the display, and then we can make any kind of measurement we want on the VSA unit. So what I will show you by now, so we have the spectrum at the moment, spectrum trace. So we have the frequency and the amplitude. So this is the waveform that has been captured. I can then focus on a different domain to be visualized. I can focus on the power versus time. And what I will do to make something more interesting to see is that rather than having a look at 100 millisecond long capture, I will focus only on a part of the burst that has been generated by the device. So let's go to the time. I will first have different windows. So the blue part you see is exactly what is shown on the bigger screen on top. So what I will do is that I will make this blue part really smaller than this, just to focus, like zooming in the trace. So I will make this smaller, just focusing, and then I will put, let's say, in the middle. So in power versus time, we can measure for sure the power that is inside the burst. We can play with markers and so on. Thanks to the VSA, I can have a look at the different domain, which is, for instance, frequency versus time, which is not possible on a spectrum analyzer. As you can see, we are still in the burst. We can see some information that is being generated inside the burst that seems to be Fsk modulation. I can make a kind of zoom inside this modulation. I will change the vertical scale just to be sure it's higher, or we get a better feeling of what we are seeing. We can make this zone really smaller than this. We can apply some kind of smoothing just to get less spuriouses. Let's see, like this. We are really seeing now the Fsk modulation inside the burst, and there is another kind of a signal that we can see thanks to the VSA, which can be seen on a spectrum analyzer, that is the spectrogram. So I will change a bit, I will remove the marker, I will change a bit the RBW that I've been using. I can change the scale just to be sure that I can see the same kind of information that we were seeing on the frequency versus time display. So by now what we are displaying is the same information. We are displaying the time, the frequency, and a kind of a three-dimension amplitude, color-coded amplitude inside the burst. What we can see here, the small bits, are the different transients that are being generated every time the Fsk is moving from one frequency to another one. So this is the kind of information we can display thanks to the spectrogram display that is not possible on the spectrum analyzer. So the interest of capturing and replay function is really to allow people to generate transients, whatever they've captured, like if it would be real time, again and again and again. As we can see, it's being generated again and again in a kind of loop, rather than just capturing the file, and once it's done, you can do it, but you cannot replay it anymore. Thanks for watching, and I hope you enjoyed this video. Do not hesitate to contact us if you have any questions, if you need any demo. We will be happy to present you this VSA function. Thank you.